Right, example 16. A small pebble is thrown upward from a cliff. Thrown upward, so let's draw a cliff konon gitu. So a ball is thrown upward with an initial velocity of 20 meter per second. Calculate maximum height reached. At maximum height, we know that the final velocity would equal to 0 ataupun the maximum height punya velocity is equal to 0. So we are looking to find the maximum height, so we can use v square u square minus 2gs. Okay, so we know that v is equal 0 for maximum height, 20 minus 2, 9.81 s. So the s we are getting from this formula is 20.39 meter. Okay, so that is maximum height which above the release point lah, above yang dia kasih buang tu. Okay, now the time taken to reach a point 25 meter below initial point. So below means negative 25 meter, and we can use s equal to ut minus half gt square. Okay, so negative 25 20t minus half 9.81 t square. Okay, then you'll reach a quadratic equation. Plug this into your calculator and then just take the positive value. You'll get the time to be 5.1 seconds. Okay, so if ada dua jawapan positive negative, we are only taking the positive lah untuk time. Right, so that is example 6. Alright, example 17. A ball is thrown straight upwards with an initial velocity of 50 meter per second from the roof of a building, in which the building is 40 meter high. Okay, so let's draw. This is 40 meter. Then we have a ball being thrown upwards at a velocity of 15 meter per second. So if a ball is being thrown like this, we know that it will fall back to the ground as well. So this part here is our h, and this one is h besar. H besar. This is the building punya height lah. Okay, right, so maximum height of the ball from the ground. So maximum height reach at point where height is maximum, we know that the velocity would equal to 0. So we can let s to be the h, where we are looking for the maximum height from the release point dulu. Okay, we are looking at this small h first. Okay, so just use the formula minus 2gs. So 0 equal to 15 square minus 2, 9.81 h. You'll then get the h to be 11.5 meter. Okay, but that is not the maximum height from the ground. So from the ground, the height would be h plus dengan the height of the building, which is 40 meter. Then you'll get the maximum height from the ground to be 51.5 meter. Okay, okay. Next, time taken for the ball to return to the original level. Okay, so for it to return to the original level, we are letting s equal to 0. Okay, so it is back to its starting point, so 0 meter lah. Okay, so what we can do is we can find using the formula as ut minus half gt square. Okay, so this one we are looking for what? The time taken. Okay, time taken for the ball to reach its original level, so we can let that equal to 0 here. and then we have 15t minus half 9.81 t square. So you will then get the value of 3.06 seconds to be the time taken for it to reach at the same level. Okay? Next, dia suruh pula cari the time taken for the ball to strike the ground if it misses the edge of the roof. Okay, so it means that berapa lama untuk dia reach the ground without langgar the roof lah. Okay, so what we can do is we can let the value to be s equal to negative 40. Why negative 40? Is because we are looking from the pergi ground. So okay, it strikes the ground. Okay, so now we can use s equal to ut minus half gt square. Okay, so negative 40 u is 15t minus half 9.81 t square. Okay, so you'll reach a quadratic equation minus 15t minus 40 equal to 0. So you'll then get the time to be 4.77 seconds. Only take positive value. Okay, positive value. Okay, is there any? Okay, so question D, last one. The velocity of the ball just before it strikes the ground. Okay, so in that case, before it strikes the ground, we can just calculate using this formula. Okay, so the time yang we are using is the time here, 4.77 seconds, which is the time for the ball to reach the ground. Okay, so 15 minus 9.81, 4.77, you'll then get the velocity to be negative 31.8 meter per second. So negative means the ball's velocity is going downwards. Okay, so I guess that's basically example 17, sorry. Okay,